This is mathheals.com, where you can go to find more links to YouTube videos, math or computers. In this section, we're going to take a look at vectors in space. Now, this is dealing with 3 dimensions, so let's talk about that a little bit. Not that I can draw this real well. We have something that looks like this. Coming out this way is our x-axis, coming out this way is our y-axis, and this is our z-axis. Now, these values coming out here, this is 1, 2, 3, and so on. Coming out here, these are 1, 2, 3, and so on. And coming up here, these are 1, 2, 3, and so on. Now, if I was going to the left over here, it'd be negative. If I was going back, it'd be negative. And if I was going down, it'd be negative. So it kind of works the same way as a two-dimensional rectangular system. You have positive going one direction, and your negative values go in the other direction. Our first problem says to describe the set of points x, y, z defined by the equation. So we got x is equal to 2. Well, x is equal to 2. If I come out here, that's going to be a can't draw a straight line. It's going to be a rectangular plane at x equals 2. And it goes forever in all directions. But no matter what, your x value is always equal to 2. So when they're asking, describe the set of points defined by the equation, well, this is a plane at x is equal to 2. Now our next one. Got y is equal to 5. Let me kind of sketch this. I'm not the greatest at sketching 3D, so you have to use your imagination on these. Okay, y is equal to 5. 1, 2, 3, 4, 5. So I'm going to have a plane at y is equal to 5. And again, it's going out in all directions, so it keeps going on forever. But y is always equal to 5. So I'm just going to write a plane at y is equal to 5. Now third one. We've got x is equal to 2, z is equal to 3. Well, let me kind of get to what it looks like here. X equals 2. Well, that means we're going to have a plane at x is equal to 2. And again, it's going in all directions. Like that. So we got a plane right there. Okay. Now our next one is at z is equal to 3. Now I'm assuming when I read this that they want us to come up with the intersection of those. And again, use your imagination on this. we got a plane there. Now here's our blue plane, and then this is coming through here. So this is trying to think of like a picture to demonstrate that. One of my planes is like this, is flat, and then the other one is, of course, it doesn't have any dimensions to it, and then the other one is up and down. So it's intersecting at one place here, and this one place goes forever like this. So this is a line, and it's a line that occurs at x equals 2 and z is equal to 3. So I got 2 here. Y can be anything. Let me put A for represent anything, and then 3. So it's a line right there. If I were to actually sketch that, I could, now that I got those, and again, those better with 3D can probably come up with a much better picture than what I'm going to do, but so one of them would be 2, 0, 3. So go to x equals 2, z is equal to 3, and y is equal to 0. So 2, and then go up about that distance, be right there. If I did another point, 2, 1, 3. So same there, but now it's 1 this way. So go to 2, over to right here, and up like that. So it'd be a line going like this. And next problem deals with the distance formula. So let me save this page actually. Vectors in space. And I'll choose C drive, temp. There we go. And trig, vectors in space. Page 1. Now, our distance formula is kind of what you'd expect. Most of these are. They're the 2 dimensions kind of extended. Given 2 points, x1, y1, z1. So it's a point in 3D, 3-dimensional space, and x2, y2, and z2. Then your distance is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Like that. Let's take a look at this problem here. We've got our first point, 3, -1, 5. And we've got our second point, 7, 1, 2. And instructions are find a distance between them. Well, this is our x1, y1, z1. And this is our x2, y2, z2. So for our distance, we have x2 minus x1, so 7 minus 3 squared, plus y2, 1 minus -1 squared, plus 2 minus 5 squared. 7 minus 3 is 4, so we got 4 squared, plus a negative becomes positive, so we got 1 plus 1, which is 2 squared. And then we got -3 squared. So I got 16 plus 4 plus 9, which gives us square root of 29. Double check my work there. Yeah. Okay. Now the next one is back to the pictures. Just kind of for us to draw a picture and then to come up with the vertices. So let me number 5. We got 0, 0, 0, and 4, 2, 1. Now what they're saying here is opposite vertices of a rectangular box whose edges are parallel to the coordinate axis are given. List the coordinates of the other 6 vertices of the box. Well, let's kind of draw this and see what it looks like. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 0, 0 is right there. 4, 2, 1. So this is our x, y, z. So go to 4 here, 2 on our y, and it's about right here. And then we're going to go up a distance of 1. So a distance of 1. So let's see, 4, 2, and then up a distance of 1. So actually 4, 2, which would be about right here. I'm going to have a point there. And then I'm going to have a point here. I'll have a point here. Now I'll do red for the other one they give us. 4, 2, 1. So I'm going to go up a distance of 1, which is about right there. Which means I'll have a point right here. We'll have a point right here. And we'll have a point right here. And if I were to draw the box, here's our rectangular box. As good as I'm going to do in 3D. Okay. So I did this one in class. I didn't use the different colors, and kind of messed me up thinking about it. So it's hard to see it without the different colors. So let's find this blue one right here. That's a distance of x is 4. Y is 0. Because like here's y1, y is 2, y is 3, y is 4. So along this axis, y is 0. And z is up 1. Okay, so that's that point. Let's do this point. X would be 4 again. Y is still 0, and z is also 0. Now let's do this one over here. X is 4 again. It goes 2 this way, so y is 2, and it's right along the bottom here, so it's 0. Okay, the blue one's back here. Let's choose this one. Well, the x is 0, because this is 1, 2, 3, 4, so right here on this axis is 0 for the x value. Y is 0, and z is 1. Now this one right down here, x is 0, y is 2, and z is 0. And then this one right here, we have x is 0, y is 2, and z is 1. And those would be our answers. Again, the main point of that problem is just to get you to wrap your mind around 3D. Now the next one talks about the position vector. And I'll go ahead and write down the formula for it. But it says we have initial point and terminal point. So, position vector. We have our initial point, which is P. And that'll be x1, y1, z1. And we have our terminal point, not that I can spell. Terminal point. There we go. Q, I'm assuming. Is that right? Yeah, Q is what they use here. And that'll be x2, y2, and z2. So our position vector, and I'll label that as a v, and I'll put a little vector over that, and very quickly I'll drop that because it's a pain to write it every time. Is going to be x2, we take our terminal minus our initial. So x2 minus x1, and then y2 minus y1, and then z2 minus z1. Like that. Well, let's take a look at this problem. Number 6. We got p is equal to -2, 1, 3. And q is equal to 5, 7, and -4. And we want the position vector. And after we get it into the form I listed up above, then we're going to rewrite it and explain what all that means. So our vector, we're going to take our x values, subtract them. Again, this is x1, y1, z1, and this is x2, y2, and z2. So we got 5 minus a -2, we got 7 minus 1, and we got -4 minus 3. Negative negative becomes positive, so we got 5 plus 2, which is 7. 7 minus 1 is 6. -4, -3 is -7. Okay, this is our position vector, but that's not how they want us to write it. They want us to write it in terms of I, j, and k. Now, these are unit vectors. I is equal to this right here, 1, 0, 0, j. I'm not, well, let me go ahead and put the vector, a little vector notation over that. This is j, which is 0, 1, 0, and k, which is 0, 0, 1. Now, this is out on your x-axis, a distance of 1. Remember, with vectors, distance is magnitude. This is along your y-axis, distance of 1, magnitude of 1. And this one's along your z-axis. Well, how in the world do we get from this to our I, j, and k? Let me write that a little bit neater there. That's our j. Well, we can split this up. We can write it as 7, 0, 0 plus 0, 6, 0 plus 0, 0, -7. We can factor our 7 out of here, and that gives us 1, 0, 0. We can factor our 6 out of here, and that gives us 0, 1, 0. And we factor a -7 out of here, and that gives us 0, 0, 1. Well, now this is the unit vector, so this becomes 7i plus 6j minus 7k. And that's our position vector. Let me save that. Next one deals with magnitude. So let's refresh our memory on that. Now, considering, remember, magnitude is your direction, basically. You get your vector, which is AI plus BJ plus CK. The I, J, and K, of course, are unit vectors. Your magnitude of V is going to equal the square root of A squared plus B squared plus C squared. That should get us ready for a problem now. There we go. So this problem, number 7, says V is equal to 2I minus 5J plus 3K. These are vectors. I won't put the little symbols over all of them. But to find the magnitude, we're going to take the square root of 2 squared plus negative 5 squared plus 3 squared. 2 squared is 4, negative 5 squared is 25, and 3 squared is 9. That gives us 34, 38, so it gives us square root of 38. Now we're also going to be doing operations with vectors, kind of like we've done before. So let's take a look at number 8. We've got V is equal to 4I. You notice the vectors are always bold when you type it out. Plus J minus 2K. And W is equal to negative 3I minus J minus 4K. Okay, and we're wanting 2V minus 5W. Well, again, the nice part about having these in terms of our unit vectors, the I, J, and K, is you can just treat them just like variables. It works really nice. So here we'll take 2 times V, which is 4I plus J minus 2K, minus 5 times W, which is negative 3I minus J minus 4K. Well, the distributive property, 2 times 4I gives us 8I, 2 times J is 2J, and 2 times negative 2K is negative 4K. And then, negative 5 times negative 3I gives us 15I, negative 5 times negative J is a positive 5J, and negative 5 times negative 4K gives us 20K. Well, green screen. I don't know what it does that. I'm going to combine the eyes together, probably because I got cheap software. But it works for the most part, so I'm happy. I didn't want to spend no $500 for tablets and so forth. Okay, combine together the i's. 8i plus 15i gives us 23i. Combine the j's. I got 2j plus 5j is 7j. And combine together the k's. I got negative 4 plus 20 gives me 16k. And that's our answer. And let's look at this one. Scroll down a little bit. We got V is equal to 4I plus J minus 2K, and W is equal to negative 3I minus J minus 4K. And we want to find the magnitude of V plus the magnitude of W. Well, for V, I'm going to have the square root, and then I'll take each of these numbers and square them. So I got 4 squared plus 1 squared plus negative 2 squared. And we're adding them together. Plus, then the square root of the W's. So we got negative 3 squared plus negative 1 squared plus negative 4 squared. So again, we take the number in front of the I, J, and K, we square them and add them together and take square root of it. So that gives us 16 plus 1 plus 4. And over here we got 9 plus 1 plus 16. Well, 16 plus 4 is 20, plus 1 is 21. So we got square root of 21. Plus 9 plus 1 is 10, plus 16 gives us 26. So we got square root of 26. And that would be our answer right there. Now these next ones are asking us to find a unit vector. It says find a unit vector in the same direction as v. So unit vector in the same direction as v. So we get u is equal to v divided by the magnitude of v. That's our formula. So for this problem, we got v is equal to 5I minus j plus 2k. And instructions say find the unit vector in the same direction as v. Well, my unit vector, and again, I'm not going to put the little vector notation over them, but keep in mind they are. So we're going to have 5i minus j plus 2k over the magnitude of v. So we'll have the square root of 5 squared plus negative 1 squared plus 2 squared. So we've got 5i minus j plus 2k over 5 squared is 25, plus negative 1 squared is 1, plus 2 squared, which is 4. Well, that's 30. And 30 is 2 times 15. 15 is 3 times 5, so I can't simplify the radical any. So we'll have 5i minus j plus 2k over the square root of 30. Want to split this up, so put 5 over square root of 30i minus 1 over square root of 30j plus 2 over square root of 30k. Now we can't have the square root downstairs, so we multiply top and bottom by square root of 30. So that gives us 5 square root of 30 over 30i minus square root of 30 over 30j plus 2 square root of 30 over 30k. And this simplifies. The 5 and 30 both divisible by 5, so that gives us square root of 30 over 6i minus square root of 30 over 30j plus 2 and 30 are both divisible by 2, so that gives us square root of 30 over 15k. And that's our answer. Yeah, I don't think I have room for the next one. Yeah, maybe I do. Dot product. V is equal to I plus K, and W is equal to negative I minus J plus K. And it says find the dot product, and the angle between them. Should actually read the directions. I don't got room. Let me save that. There we go. And actually, let me go ahead and write the formula up first, and then we'll talk about it. So we got V is equal to A1I plus B1J plus C1K and W is equal to A2I plus B2J plus C2K. Now our dot product of the two vectors, we multiply the numbers before the i's, so we got A1, A2, plus, and then you multiply numbers before your j's, so we got B1, B2, plus C1, C2. And this is our dot product. Now the angle between these two, cosine of theta is going to equal to the dot product of V and W divided by the magnitude of V times the magnitude of W. Now actually the times here, I'll put a little X like that to indicate multiplication. Not to be confused with the dot product up on top. Okay, now let's look at our problem. 11. We got V is equal to I plus K, and W is equal to negative I minus J plus K. First thing, our dot product. We'll multiply the numbers before the i's. So we got a 1 here, we got a negative 1 there. Then we'll multiply the numbers before the j's. There is no j on this one, so that's 0. And number before this j is negative 1. And then number before our k's. So we got 1 times 1. So that's our i's. This is our j's. And this is our k's. Well, 1 times negative 1 is negative 1. That's 0 times anything drops away. 1 times 1 is 1. So our dot product is 0. Okay. Now the angle between these two vectors would be cosine theta is equal to the dot product of V and W over the magnitude of V times the magnitude of W. Well, the dot product is 0, and 0 over anything, assuming it's not 0, which it isn't, is equal to 0. So I don't even need to really do much work there. Now we'll take inverse cosine of both sides. And this one's pretty obvious because it's on a unit circle, but let's go ahead and show it on the calculator. We got theta is equal to inverse cosine of 0. Well, you need to make sure you're in degrees on your calculator. So if I press mode, you see the third one down. I press down arrow to that, put my flashing cursor on degree, and I'll press the enter on it if it's not already highlighted. Mine is, so I don't need to do that. But then second mode, exit out. Okay, we got inverse cosine of 0. So I do second cosine. That's also called arc cosine. And then I put 0 in. And it tells me 90 degrees. Which is the angle between them. Which isn't surprising because our dot product came up as 0. So that will lend you to find that the angle between them is 90 degrees. And because of the dot product is 0, that implies they're orthogonal, which in normal terms, if we weren't talking about vectors, would mean perpendicular. I think we got one more of those. There we go. Then we're going to take a look at the direction angles. Now in this one, we got V is equal to 2I minus 3J plus K. And W is equal to I minus 4J plus 2K. Okay, first thing, dot product. So find dot product of V and W. So multiply the numbers before the i's. So I got 2 times negative 1. Multiply the numbers before your j's. So I got negative 3 times negative 4. And multiply the numbers before your k's. So I got 1 times 2. So that gives us 2 plus 12 plus 2, which gives us 16. Like that. The angle between them. We're going to have our dot product up on top. And then we have our magnitude of V times our magnitude of W. Well, up on top is 16. The magnitude of v. I'll have the square root, and then I'll square the number before the I, j, and k, and add them together. So we got 2 squared plus negative 3 squared plus 1 squared times the square root of w, which is 1 squared plus negative 4 squared plus 2 squared. Okay, so that gives us 16 over square root. 2 squared is 4, 3 squared is 9, 1 squared is 1. So I got 9 plus 1 is 10, 14. Then the square root of 16 plus 4 is 20, plus 1 is 21. Now just be careful when you plug this in. Anytime you have more than a single number or a single variable on the top or bottom of your fraction, you have to put parentheses around it. So when I plug this in, I had to put parentheses around the bottom. So let's go plug this in, see what we get. So do inverse cosine of 16 divided by, we have to put parentheses around the bottom part, square root of 14, so I do second x squared, 14, put a closing parentheses on 14, or square root of 14, times, and then second x squared, square root of 21. And closing parentheses on the square root of 21, closing parentheses on the denominator, closing parentheses on the inverse cosine. You don't actually need to put any of those in. TI3, TI4 is very forgiving about closing parentheses at the very end. And then enter. And we get 21.1 degrees. Now the dot product is usually used in another formula to help you solve something. So by itself, you can't look at this and say 16, that means this or means that. It's used to help you in other formulas. Save this. Then we'll take a look at the direction angles. There we go. Can't draw this real well. You have to use your imagination. Okay, so we have a vector here. It's going out in space like that. Well, there's a certain angle that it makes with the x-axis. That right there, that would be your alpha. And there's a certain angle it makes with our y-axis. That's our beta. And there's a certain angle that it makes with our z-axis. And I believe this is gamma. It's been a long day. See if I can find it in the book. If not, we'll pretend it is. Acute angle, blah 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 blah. I'm kind of weak on my Greek alphabet. Yeah, I think it's gamma. I don't see it anywhere. We'll pretend it is if it isn't. And we got our direction angles. How to find those three? Well, our first formula is cosine alpha is equal to, and this is assuming. Actually, let me write down the vector first. This is assuming our vector is equal to AI plus BJ plus CK. Given that, and of course then what goes along with that is our magnitude is the square root of a squared plus b squared plus c squared. Then we have cosine of alpha is equal to A over the magnitude of V. Now A, B, and C are just numbers. And cosine of beta is equal to B over the magnitude of V. And then cosine of what looks like Y, gamma again I think, is equal to C over the magnitude of V. There we go. So let's use that to solve some formulas. Where's this used at? Well, you go into some aspects of physics, and putting things in 3 dimensions works out nice. How do I know that? Am I like some kind of genius? I went and asked our physics expert. I said, "What's a physics applications where you see this?" And he said it's not used very much. And this guy has a PhD in it, so pretty sharp guy. I haven't had physics for 20, 25 years, 26 years, and he says you only see it a little bit, so it's not that important part of a trig. But okay. Now, since it's in this form, our A is what's before our I, which is 1. Our B is what's before our J, which is 0. There is no J. And our C is number that's before our K, which is 1. Let's first find our magnitude. So we've got square root of A squared plus B squared plus C squared, which is going to be 1 squared plus 0 squared plus 1 squared, which gives us square root of 2. Now, actually, I'm going to skip ahead on those. We want alpha, beta, and gamma by themselves, I think. That's what they're asking. So, yeah, one by himself. So we're going to take inverse cosine of both sides. So alpha is going to equal to inverse cosine of A over the magnitude of V, which gives us inverse cosine of A, which is 1, over square root of 2. So inverse cosine of 1 divided by square root of 2, so second x squared and 2, and we get 45 degrees. And then to find our second angle, we're going to have B over the magnitude. So B was 0. So 0 over square root of 2, which is 0. So we come over here, do our second cosine, put in 0, 90. And then our last one. You can see they're not that difficult problems. That's not supposed to look like y, but as good as I'm going to get. Okay. So then we're going to have inverse cosine of C, which was 1, over square root of 2, which is the same as the first one, 45 degrees. And those would be our answers. Now those kind of make sense based upon that these are ones when you think about it. If you were to actually graph this and so forth, it's like, oh, okay, yeah, that makes sense. Here's our x-axis, our y-axis, and our z-axis. So we got 1, 0, 1. This is like your x, y, and z. So we got x, y, and z. So probably won't be able to draw it very well here. Maybe I help if I made those a little bit bigger. Okay, let's say this is 1, and then this is 1 here. Okay, so that's x, y, and z. So x is 1, y is 0, and z is 1. So I go up, and here's a distance of 1 on the z-axis. So from right here, I'm going to go up a distance of 1. That's what makes it proportional. Or as close as I can get. So when you look at it, in terms of the x-axis and the z-axis, if I rotated the view, it'd be lined up perfectly, which means that this right here has to be 45 degrees. This one here has to be 45 degrees. Based upon that, this is 1 and this is 1. And then, of course, coming from over here, it makes sense it'd be 90 degrees. Now going from over here to the vector. Now the next one won't be as obvious as that. I think I made the numbers up, so let me save that and start a new page. Just make sure I have enough room. There we go. Okay, so let's look at this one. So we got v is equal to 2I plus j. Remember, these are all vectors, minus 3k, except for the numbers out in front. And we need to first identify our a, b, and c. Well, a is numbers before your 2, or before your I. B is numbers before your j, which is 1. C is a number for your k, which is negative 3. We need our magnitude, which is the square root of 2 squared plus 1 squared plus negative 3 squared, which gives us 4 plus 1 plus 9, which is the square root of 14. Okay, so our first one. A over the magnitude of V, which would be A, which is 2 over the square root of 14. Now again, you want to make sure you're in degrees on this, by the way. Mode, and then you want degrees to be selected here. Okay, so I'm going to do second cosine 2 divided by second x squared for the square root, and then 14. And we get 57.7. Second angle. Got b over the magnitude of E. So inverse cosine of 1 over square root of 14. Divided by the square root of 14. And we'll get 74.5. Then our last one. Got c over the magnitude of E. C is negative 3 over square root of 14. Negative 3 divided by second x squared 14. 143.3. And that would be our third answer. So I'm going to save that. Now I'll stop the recorders. Oops. There we go.